All right. Good afternoon, everyone. My name is Mapule Molabi. I am the founder of Gr11&12, and I'll be your tutor for this afternoon. Maybe if I may, because since it's not a lot of us, can I please get you guys' names? I know Ava Kolwi and the other guys. What are your names? And to which school do you go to, in which province? Yeah, just those things.
Oh, hi. Siyabonga Gomezulu. I'm in province of Limpopo, going North Trust Academy during grade 12.
Oh, okay, thanks. Yeah, and even the grade will help. Who else is on the line?
I am Andy.
You are Andile? You are in which grade, Andile? Okay, maybe Andile's network is not good. The next person, Avakolo, you are in grade 12 also, ne?
Yes.
Okay.
Okay, I'm Andy Safara's Gr11 KZN during grade 12.
Oh, all right. Okay, so we've got grade 12 so far. Okay, let's start. It's fine. Those that join later, they will just catch us along the way. Okay, so we're gonna do functions and trigonometry. And on functions, we're just gonna do, it's just gonna be a quick recap. I'm not gonna go into detail. I'll only go into detail on trigonometry. So on functions, I just wanted to show you guys the translations and reflections of the graphs. But I'll just go and get the formulas for different functions. So we've got a parabola. So the first one it should be a parabola. Okay, so the formula for a parabola, it's a general formula is in this form: a into x minus p, a exponent 2 plus q, where the p it's the vertical horizontal shift. So if this is your parabola and this is your p, the p is just telling you how the function, the graph or the function will shift in the horizontal or the x, in the x direction. So p is the horizontal shift. If they had given you a formula and then they now change it and say maybe they say -2, then you know that it will shift either to the right or left by that 2 units. So that's the p. And then we've got q. This is a horizontal shift. We've got q. Q is a vertical shift. Q is a vertical shift. Okay, someone is saying it's not showing the video. Just hold on a sec. Can you guys can see the screen, ne?
Yes.
Oh, okay.
Yes.
Okay, so that's the vertical shift. And then we've got the turning point. That's where your graph turns. So turning point, like here, this will be your turning point. So turning point, actually coordinates for turning point is the P and the Q. Those are your coordinates for the turning point. Okay, sorry guys. This one, she tried to log on earlier. I was still not connected. So she cannot see the screen apparently. Okay, right. So we've got the turning point to be P and Q. And then also this A, it's just telling you whether the graph is looking up or is concaving down. So that's just the shape of the graph. So if your A is greater than 0, that means your graph will concave up. The graph will look up. And then if your A is less than 0, your graph will concave down. So it will look like that. So I'm not gonna, yeah, that's all that I'm gonna do here. So if they tell you that your graph will shift, they add something like this, like maybe they say on that function they've given you, they add plus a certain value, let's say plus 5. So if you've got this minus p, right? It means your graph will shift p units. It will shift p units to the left. If it's a minus, right? Then if you've got plus p there, that means the p will shift p units to the right. Okay, and then q, we said q is gonna move the graph up, either up and down, right? So if you've got a plus q, so this will normally be where you've got x, you have x minus p, where you have x is x plus p. And on this one, you will have that original function, but they will say, let's start with a minus. They will say minus q. So if it's like this, then your graph will shift q units up. Wait, let's see, no, with a minus down. So here, your graph will shift q units up. Then if you've got plus q, that graph will shift q units down. Oh, jeez. Why am I confusing this? Sorry, guys. And guys, if I'm making a mistake, please correct me. Ne? I do make mistakes. So if I'm making a mistake, don't let me carry on. So if you've got minus, it will shift those q units, if it's 5 or 10, down if it's a minus. And then if it's a plus, it's gonna shift up. Okay, so that is that. So this is a parabola. And this is applicable for all types of graphs. So if they change the value, but we'll just do one example. When we do an exercise, you will see this part. Then let's try, let's look at the next function, which is a hyperbola. So the next function is hyperbola. Okay, so the general formula for hyperbola, you have y is equals to a over x minus p plus q. Then the p, it will still shift your graph horizontally. So it's a horizontal shift. Your q, it will shift the graph vertically. The same way as on the parabola. Then your also p is the vertical asymptote. P is the vertical asymptote, while the q is the horizontal asymptote. So an asymptote is just a line where, or it's a barrier where your graph cannot touch that line. So when you draw your graph cannot touch that line. So the q is the horizontal asymptote. So a hyperbola graph, it looks something like this, right? Then this will be your x is equals to q. This is a horizontal asymptote. That's your horizontal asymptote, right? So your graph cannot touch this line. And then if I draw this one, this will be your vertical, y is equals to, no man, this is p, not q. So this is p. Then a vertical asymptote, you have y is equals to q. So this is your vertical asymptote. This is your horizontal asymptote, okay? Also, p, it shifts your graph horizontally, q shifts your graph vertically or up and down. And then the a, this a, it just shows you where your graph is gonna lie, whether your graph is gonna lie in the first quadrant, second quadrant, third quadrant, or fourth quadrant. So this value of A or the sign of A, it just shows you where your graph is gonna be. So if A is greater than 0, that means your graph will lie in the first and the third quadrant. If your A is less than 0, your graph will lie in the second and then in the fourth quadrant. Then what else is on the hyperbola? Let's see. Then we've got axis of symmetry. If they ask you about axis of symmetry for a hyperbola, you've got equation y is equals to x minus p plus q, and also you've got y is equals to equation negative x minus p plus q, which you rewrite it or simplify it is negative x plus p plus q. So if you were asked to also get the equation of axis of symmetry for a hyperbola, these are the points that you need to use. Okay, and then also you've got the point of intersection on the hyperbola. So if they ask you about point of intersection, you'll have two pairs because you've got these two lines, these two equations. So if your A is greater than 0, then your points of intersection, you will have them like this: a positive square root of A plus P, and also positive square root of A plus Q. And the other pair will be negative square root of A plus P and negative square root of A plus Q. That's if your A is positive. Then if your A is negative or less than 0, then you will have your points of intersection as negative root A plus P, and then positive root A plus Q, and then the other pair will be positive root A plus P and negative root A plus Q. So that is that's the hyperbola graph. So that's all I'm just going to go through. But when they tell you now that your hyperbola you are adding is to be the same thing, when they say now you were given f at x as a hyperbola, but now they say now that graph now you are adding something to the x, right? If let's say, for example, they say now you've got x minus 2. So what is happening to that original function? We said if it's a minus, that means your graph is going to shift 2 units to the left. Then if we had x plus 2, your graph will shift 2 units to the right. Then if this was like this, then plus 5. You see, they are adding a y value. Unlike here, you were changing x. Instead of x, it was becoming x plus 2. Now here, you've got the function, but you are adding a q value. So if it's a plus, that means your graph is going to shift up by 5 units. If it was minus 5, your graph will shift down by 5 units. Okay.
Come on, man, go my question to study.
Please mute. Please mute, guys. You can put it back on and mute when you have a question. Baby Dancy, you are talking. There are people talking in your background. Okay, so that is the hyperbola. If you guys have questions, please, you are welcome to ask. Don't send message on the inbox because I won't be able to go there. So if you have a question, you can just ask me here. Okay, so then the next one is the exponential graph. Exponential function. Okay, so the general formula for exponential function, you have y is equals to ab exponent x minus p plus q. Okay, where b must be greater than 0 and then b cannot be equals to 1. Then if the value of A is positive, A greater than 0, the graph will lie above the asymptote. So if this is greater than 0, your graph will lie above the asymptotes. Then if A is less than 0, your graph will lie below the asymptote. To lie below the asymptote. Okay, and then the P, here's the P. The P will once again shift the graph sideways, left or right, which is horizontal. So it will shift the graph horizontally. And then Q, it will shift the graph vertically. So the same way on the other two functions. And then also Q is the horizontal asymptote. So Q is a horizontal asymptote. Okay, so if you've got your, let's say this being your asymptote, maybe this is y is equals to 3. Then, and if your A value was positive, then you know your graph, you have to draw it above this line. And then if your asymptote was, again, y is equals to 3, but the value of A was negative value, then your graph must be below the asymptote. That means that graph, you're gonna draw it somewhere under that line. It must fall under that line. So this just helps you to see if when you're drawing your graph, are you doing it right? Because by the time, if you see over here, you've got a negative number, you know your graph must be below your line of asymptote. So I think that's about it on the exponential function. Then we've got trigonometric functions. Okay, maybe before I go to trigonometric functions, so the shifting, it will also still be the same. So if you had your f at x, and then now they tell you that now you've got f at x plus 2, that means the graph will shift to the left. Let me see again. Plus p, yeah, it will shift to the left by 2 units. So 2 units to the left. If you've got f at x minus 2, the graph will shift to the right. Okay. Then if now they tell you your graph now is f at x plus 2, now that 2 is a q. So that means your graph will shift up by 2 units. So it's the same thing applies. If it's f at x minus 2, the graph will shift down by 2 units, okay? Then there's also something called the reflection. So if they tell you that your function is reflected about the x-axis, so this is the x-axis, right? Let's say you had equation of a straight line there. Let's say here is minus 2, here is 2. Then they tell you that the graph has been reflected about the x-axis. So if you are reflecting about the x-axis, that means y becomes negative y. If the graph is reflected about the y-axis, this was x-axis. If it's reflected about the y-axis, that means your x becomes negative x. So if you find a question where they tell you that this graph has reflected about the x-axis, what is the new equation? So you must just know wherever if it's reflected about the x-axis, wherever you have y, that y becomes negative y. Then you rearrange it and make y the subject, then that will be your new equation. So that's what you do that. Okay, so that is just the reflection part. Then let's look at the trigonometry. Then trigonometric functions. Okay, so trigonometric functions, we've got y is equals to cos x, we've got y is equals to sine x, we've got y is equals to 10x. Okay, so and normally they will give you this range where x is an element of minus 360 and 360 degrees. So we'll start with the cos function. So when they ask you to draw a graph like this and they give you this, don't please read this part, because it's not all the time that you find that your domain or these are just limitations where you draw your graph. So you're drawing it from minus 360 to 360. So don't forget to read that part. Sometimes it doesn't start at minus 360. Sometimes they say it starts from 90 until 360. And you find when you drew your graph all the way from minus 360, then you're gonna lose marks there. So this is very important. This they are telling you how far are you gonna draw your graph. Okay, so we've got cos x. So let's try to draw a y is equals to cos x. So minus 90, minus 180, minus 270, minus 360. Then 90, 180, 270, 360. This is 1 minus 1. That's your x and your y axis. Okay, so let's check now on our calculator. Let's start with minus 360. So cos negative 360 is positive 1. Let me just put this line here just to make it easier for me to draw. Okay, so cos 360 is giving me positive 1. So we've got 360 and positive 1. Then cos negative 270 is 0. Cos negative 180 is minus 1. So here. Cos minus 90 is 0. Cos 0 is 1. Cos 90 is 0. Cos 180 will be minus 1. Let me just see if I'm correct. Okay, then 0 and then there. Okay, so this is going to be your graph. That's your graph. Then let's say here they've told you now that actually the range, not the range, this is the domain that is from minus 90 until 180. Right? That means you're only gonna draw your graph from minus 90 until 180. This will be your graph. You won't draw the whole cosine graph. So this is important. You need to look at this. Okay, so that's a cosine graph. Then let's look at the sine graph. So you have y is equals to sine x, where x is a same domain, minus 360 and 360 degrees. Okay, so sine, I'll start with 0. Sine 0 is 0, 90 is 1, 180 is 0, 270 is minus 1, and here, so this will go the side here, here and here. Sine 360 is 0, ne? Yeah. So this is going to be your graph. This is your sine graph. Okay, so that's your sine graph. Then, okay, tangent, we'll draw it separately. Then on this one, then there's you need to know the period of the graph. Okay, so the period of the graph of a sine graph is 360. Okay, so a period is just like a complete cycle. Can you see if we draw from 360? Can you see here? This is half a cycle, and from here to there is 180. Then if we do this, this makes it a full cycle. Then that's 360. So that's the period of the sine. Yeah, that's the sine graph. So the period for the sine graph is 360 degrees. Okay, and then they will ask you to do a domain if maybe it was not given. This is a domain. If they didn't give you, maybe they gave you a graph. Now they ask you, what is the domain for this graph? So domain, it will be X is the element of, you check where your graph start. Can you see your graph start? You always start from negative to positive. even when you do the range, you start from the negative, you go up on the positive. So on the negative side, our graph starts at minus 360 degrees. If we go all the way, it ends at positive 360 degrees. Then you've got an open bracket and a closed bracket. If a value is not included, you're going to have that open bracket. If that value is included on the graph, you're going to have the closed bracket. So if you see here, 0.360 is actually included. That's why we'll have it as a square bracket like that. Unless if maybe they have drawn a graph, let's say something like this, and you have this an open or an open dot, not a solid dot, unlike this is a solid dot. So if you have a solid dot, it means that point is included. That's where you're going to have your square brackets. If you've got an open bracket, then you're going to have that means the value is not included. Whatever is after that value, whatever that happens, but this value is not included. So that's what that open thing, that open circle means. If it's a solid, and then it means the value is included. If it's just open, then that value is not included. Then you're going to have round brackets or open brackets. If it's included, you're going to have square brackets. Okay, so that's that part. Then what else is here? Then the range. This is for the sine, still for the sine graph. So the range is the y value. So if you come like this from the negative side on your y side, can you see the minimum value of the sine graph is actually 1, -1. So that means y is an element of, it's a -1. And then what is the maximum value when we go up? The maximum value for this graph is +1. And those two values are also included. So we're going to have square brackets. Okay, so that's that. Guys, if you've got questions, you are more than welcome to ask. Okay, yeah, so that's that. So it is the same. Can you see? Actually, this is the same for both a sine and a cosine graph. The period is the same, the domain is the same, and the range for the cosine and the sine graph. Okay, so that's a sine graph. Then let's look at the tangent. Okay, before we go there, maybe let's look at this. So a general formula for a cosine graph, you have y is equals to a cos x, you have y is equals to a sine x, you have y is equals to a tan x. Okay, so this a here, this is the amplitude or the height of the graph. So you see from here to there, this is actually the height of the graph. So that is a. So you see on this one, the height of a cosine graph, can you see the a value on the one I drew is 1. The a value for the sine graph is also 1. Okay, so this is the value of a. Okay, then on the, even on the tangent, it's the same thing, but we haven't drawn the tangent graph. So a, it changes the amplitude or the height of the graph. Okay, so if your cos, let's say cos 270, cos 270 is 0, right? Then now instead of your function being cos x, now it's now cos 2x. So it means that your function, the height of your graph is gonna change by this. So cos 270 is 0, multiplied by 2 is still gonna give you 0. But let's look at something that is gonna give us 1. Cos, where is the cos 1? Cos 0. Cos 0 is 1. Now 2 cos 1. 2 cos 0 degrees. This is gonna give you 1 times 2 times 1, which is 2. You see now the height of the cosine is now gonna change. Now it's gonna turn here instead of turning at 1. But everything else remains the same because cos 90 is still gonna be 0. Then cos 180 is gonna be -2. 270 is still gonna be 0. 360 is going to be at 2. So your graph is actually just expanding. It's either it expands or compresses vertically. This is what that value does to your function. Okay, so your graph will now look like this. Still come. It will still come here, go down to 2, and end somewhere there. Okay, so that's that. What the A value does, it's the amplitude of your graph. It's just the height. Okay, so if you were given this green graph and they tell you that this is, let's say this is 3, they've shown that value on the graph. Then they ask you, what is the equation of the graph? So you look at the height of the graph. So you see the height of the graph is your normal graph. You see, okay, this shape is a cosine because it's not starting at 0. Remember a sine, what is this? Am I mixing this thing? The black one is a, what is cos 0? 1. Yeah, it's a cosine graph. So you know a cosine graph, it doesn't start at 0. So then you know, okay, it's a cosine graph, and you know cosine is cos A cos X. So we know it doesn't start at 0. So that means the value of A will be 3 because that's the amplitude. It will be 3 cos X. And you see the other angles, they are still at the origins. Everything else is still there. The only thing is the amplitude or the height of that function. So that's that part. Okay, so that's the A, what the A does there. Then let's look at the other things. Then if now you are given okay, now you are given y is equals to sine x plus or minus q, or y is equals to cos x plus or minus q, or y is equals to tan x plus or minus q. So now let's look at what the q does to the function or the graph. So the value of q is going to shift the graph up and down, just like on the other functions. The value of q, it shifts the graph up and down. Okay, so if it's plus q, it's going to shift the graph upwards. Okay, if it's minus q, it's going to shift the graph downwards, okay, by that q units. So if they said now, instead of this cos x, now it has become y is equals to cos x plus 3, okay? So that means the original cos graph was sitting here, right? So now it's actually, it shifts the whole graph up, not just the height. Now it moves the graph upwards, okay, by 3 units. So everywhere the graph here was at 1, is gonna move up by 3 units, sit somewhere there. Here it was here, you move 3 units, maybe it sits here. So everything moves 1, 2, 3. So your whole graph is just gonna move up by 3 units. If it was minus 3, your graph was gonna move down, shift down. All the points will just shift down by 3 units. Then you draw your new function. Okay. Then the other scenario is, let me change the pen. When you've got y is equals to sine kx, y is equals to cos kx, y is equals to tan kx. So it doesn't matter on which one, whether it's on a tangent or a sine or a cos, they do the same thing. So here, your k now, it changes the period. So it stretches your graph or compresses the graph when you have this now, because it means instead of 0, you now have 0 times that the function here, whatever the value k will be. Instead of 90, now it's going to be 90 times that value. If maybe it was 2, then it's 90 times 2. And then they say if here, if k is between less than 1 and greater than 0, your graph will be stretched. So if this k is between 0 and 1. So your graph will stretch. Okay, and then your period will increase. Remember now, if your if your graph stretches, that means that complete cycle is also gonna grow bigger, because now you are pulling your graph further away. So the graph is gonna stretch, and then the period is gonna increase. And then if k is greater than 1, the graph will be compressed. Okay, so the graph will be compressed if your k is more than 1, and the period will decrease. Okay, so then your new period, because when that happens, then the question is going to come. They ask you now, what is the new period if the graph have shifted in this manner? So your new period will be the old period divided by that k. So if k was 2, your new period will be, the period for the cosine is 360. So that means if k now was 2, the new period will be 360 divided by 2. That means it will be 180. Even for the cos graph, the period is 360. If your k now is 2, you're going to say 360 divided by 2. The period for a tangent, even though we haven't drawn it yet, it's 180. So the new period will be that 180 divided by that value of k. So that's that. Let me see what's next here. Okay, right. So let's just see the time. Let's just draw the tangent one quickly. Or are you guys fine with that? Should I draw it or not? Guys, should I draw the tangent? Anybody home?
Yes, draw it.
Okay, right. So let's look at the tangent. Y is tan x. So if we say the domain is between minus 360 and 360 degrees, okay? So we've got 1 minus 1, 90, 180, 270, 360, minus 90, minus 180, minus 270, minus 360. Okay, so if we take our calculator now and punch in the values of x on that equation, so we're going to start with 0. Tan 0 is 0, so we are here. Tan 90, if you guys, you check on your calculator also, tan 90 is giving you an error, so this graph is undefined at 90. Tan 180 is 0. Tan 270, it will give you an error, so the graph is undefined here. These are called asymptotes, remember. So that's where your graph does not touch. These are asymptotes. So they will tell you, when they tell you to draw the graph of tangent, they will tell you to show asymptotes. This is what they expect. This dotted line, those are just showing your asymptotes. So they'll tell you, show the asymptotes, show the coordinates. So these are the asymptotes. So negative 90 also, the graph is undefined there. So we have an asymptote there. We have an asymptote here on minus 270. So there will be a mark for you showing this. Then everything else, if you use your calculator, these are zeros. Then you see we can't draw our graph like this. So that's when now we put additional values now. We put 45, 135, 225, 315, minus 45, minus 135, minus 225, minus 315. Okay, then tan 45 is 1. Then minus 45, it will be minus 1. So it will look like this. So remember, the graph cannot go over your asymptote. So your graph from here, it will just go straight down. It can never go the other side, okay? Then let's see tan 135. is -1. So we have -1 here. Where did I put -1? Okay, let me just put it here because now. Okay, so this is our -1. So it's here. What is, no, not this, 45. Where am I? Side. This one, then 2 to 5, it will be +1. So your graph will be like this. It must not go over. It's just gonna go closer to the line, but it can never cross that line. Okay. So tan 315, it's -1. So we are somewhere here. So the graph will be like this. And then this side, tan -135 is +1. So this one will be this side. So we have something like this. Then 315 tan -315 is +1. So we are like this. Okay, so this is your tangent graph. Then now, what is the period for this tangent graph? We said the period is your complete cycle, right? So let's look at this one in the middle. If the cycle will be complete, can you see this graph? The only way it's mirrored is this side up until that side. So can you see the complete cycle is actually from here to there? So, and what is that value? So from here, we said it's 0 is 45. That means 90, 135, 180. That's why the period for a tangent is 180 degrees. And then the range, okay, let's start with the domain. Domain, remember, is the x values. So x is an element of what? So on a tangent graph, you will have so many values because you see your graph is cut everywhere. So you will have, your graph will be between, let's say, the side. So they won't, I don't think they will ask you to do a domain for a tangent graph, but I'll just show it to you. So the domain, we are coming here. So the graph starts at -360. So that means your x here is an element of -360 until, can you see where it ends? It ends at 270. Mara 270 is not included because your graph is not allowed to touch that 270. That means on 270, you're going to have a circular bracket or an open bracket. But on -360, because that value is included, we have a square bracket. So they won't ask you a domain for tangent because it's too many values. So after this line, you will have another domain. So after 270 line, you'll have another domain where x is actually between is an element of 270. Okay, these are all negatives. -270 up until -90. 90 is not included. 270 is not included. And this you can also write as is less than -90 greater than -270. Remember, if the value was included, you were going to have less or equal and greater or equal. But because those values are not included, that's why we don't put the equal sign there. So then you just gonna continue like that. But like I said, they will not ask you to write a domain for a tangent graph. So they will only ask you the range. So because the domain is, they're divided, there are so many of them. So let's look at the range for this. So we said the range, you are coming from the negative side of the y, you're going up. Where does the graph start? Can you see this graph can go all the way down? We don't until when, as long as it doesn't cross over your asymptotes. So that means what the y is an element of -infinity. You see when you go up, these graphs can also go up. They don't end. Unless if they have shown you by a dot that the graph ends here, they give you a coordinate or a solid dot. Otherwise, it goes all the way to +infinity. A -infinity is not included, so you have open brackets on the infinities. So that is that. What else is missing here? We've got the domain and the period and the range. Yeah. Okay, so that is the tangent graph. So if now they had said now instead of y is tan x, now you have y is equals to 2 tan x. Remember this value of a it's the change in your amplitude. So instead of 1 now, your thing is gonna be 2 instead of 1. So your graph is just gonna, this point is just gonna move to 2. This one is just gonna move to -2. That's what the graph does. Okay, so it stretches up. Okay, then if now you have maybe tan, what's this, x plus 2. We said that that one, it moves the graph in the horizontal, right? So you have your tan x, which was, let's say, tan 0. Tan 0 was a plus 2. Tan 0 is 0. Then we add, what is this? No, it won't be, it will be plus an angle here. Maybe let's say plus 20 degrees, okay? So it will be 0 plus 20 degrees. That means your graph is shifting to the right. So if we say tan 0 is 0 plus 20. So your graph is shifting to the right. So instead of being at 0, it's gonna start somewhere here. So that's what your graph does. That's what this thing does, okay? Then the last one was this one, tan 2x. We said this thing changes your period. So you see now, instead of tan, okay, let's not use 0. Instead of tan 45, you're gonna have 2 times 45. Now it's gonna be tan 90. So, and then once you have this, it changes your period. When they ask you what is the period for the new graph, it's gonna be the old period divided by this value there, 2. So the old period, the period of a tangent is 180 divided by 2, which means the new period of the tangent is 90. Okay, any questions? So that's about it on the functions. Then we can do, what's this? We can do an exam question before we move to trigonometry. Anyone with a question, please, you are welcome to ask now. Okay, I assume no questions. Then let's move on now. I've sent you guys, if you guys were on that WhatsApp group, I've sent you guys the questions that we're gonna do. So let me just go there. Do we have any grade 11 here? Because I see now there's 2 more people. The ones I had before, they didn't have, they were all in grade 12. Is there anyone doing grade 11? You can mute and let me know. Anyone doing grade 11? Stop sharing here. Okay, I assume no one. Okay. Please let me know if you can see the screen. Can you guys see the screen?
Yes.
Yes, I can see.
Okay. Yeah. Okay, so I'm gonna just page through. You guys tell me which one I should do, because I won't do, they take time. So this is this one. These are all from different question papers. Another one is, this one is grade 11, but I assume there's no one from grade 11, but these questions are the same, whether you're in grade 11 or 12, they ask them the same way, or they are all difficult if they're difficult. So I've got this one, and then I've got this one. So you guys, you're gonna choose, you tell me which one I should do. Let me see if there's another one. Yeah, I think it's only these 2. Yeah, okay. So which one should I do? Question 6, this question 6, or this one? You see, 23 marks, 20 marks. This is grade 11, this is grade 12, but it doesn't matter. they can ask you this one even if you're in grade 12. So please guys, let me know which one should I do. You have them, I've sent them. If you were in that WhatsApp group, I've sent them there also. So which one should you do? Should I do? Choose please.
The first one.
This one. You mean this one, ne? Okay, so let's look at this. They say in the diagram below, A and B are the x-intercept of the graph. So I'm gonna remove this. So let's just read for now, because I need to go back to the screen where I can write. So in the diagram below, A and B are the x-intercept of the graph, okay? The graph is f at x, which is equals to x squared minus 2x minus 3. And you know, if they say x-intercept, that means your y is 0. So already you can put your y as 0 and then factorize, solve for x here, get the x values. Then you're gonna get the coordinates of A and B, okay? And then they say, while you're still there, you can also get the y-intercept. That means you put your x as 0. So everything will be 0 here, and then your y will be minus 3. So you'll have the coordinates for the point where you have is here. They didn't show it. But now you see A and B already, you see where you're gonna get the coordinates. Then they say a straight line G through A cuts F at C. So a straight line G, it goes through A and it cuts the F graph at C, which C is coordinates are 4.5. And then the y-axis at 0 and 1. So they're giving you the y-axis for that line G. Then M is the point F, and then N is the point on G. M is the point on F, N is the point on G, such that MN is parallel to the x-axis. Okay, so when a line is parallel, Kana, what does it mean? Can anyone tell me when you have got parallel lines in terms of the equations? If you've got lines that are parallel, it means their gradients are equal, right? If lines, lines are perpendicular, when you multiply the product of their gradients, then they're supposed to give you -1. So here they're telling you that that line MN is parallel to the y-axis, and a y-axis, it doesn't have a gradient. The gradient is 0. So that means even this MN, the gradient will be 0. Can you see that if they were to ask you what is the equation for MN, can you see it's gonna be x is equals to a constant. We just need to find that constant if they were to ask you that. Okay, then they say MN cuts the x-axis at T. Okay, so that's that. Now let's go. Let me just open the graph on my book, because I'm not gonna okay, maybe I need to draw. But where is it? Let me just get that. This one, yeah. Okay. Right, so now let me go back here. Right, so I think I'll need to draw it. So let me just try to draw it quickly. So we've something like this. We've got the straight line. And then we've got this N, this is T, this is M, this is Y. This is G, this is equation F, this is B, this is A, this is 0. They showed you this is 1. Okay, they told you that line G, it has the y-intercept of 0 and 1. Ne? And then this was point C. They said it's 4 and 5. Then what else is there? Okay. Then the first question, they say, show that a gx is x plus 1. So the first question, they say, show that by means of your calculation, show that gx is x plus 1. Okay. So G is the straight line again. So it's this line. So we want the equation for that. They want us to find this equation. Okay. So, and they gave us that the y-intercept for G is 0 and 1. So you know the equation of a straight line, y is mx plus c, and you know that c is the y-intercept. Already we know c is 1 because they told us the y-intercept is 0 and 1. So that means your graph is y is mx plus 1. Okay. Then you know again that that line G, it cuts the graph F at point C. They gave us coordinates. So you've got a coordinate that is on that very same line. So we take these coordinates of C, we substitute them here, then we get our value of M. Then we can have our equation. So we have 4 and 5. Y is 5. The value of X is 4 plus 1. So if I bring 1 to the other side, I'll have 5 minus 1. It gives me, we have 4M. So that means 4 is 4M. Can you see now the value of M is 1? Therefore, this equation is X plus 1. Okay, so that's question number 1. Then question 6.2, calculate the coordinates of A and B. I've already talked about this one. So they gave you the equation of A and B. Can you see is the X-intercept of graph F. So equation of F at X, they gave us, they said is X squared minus 2X minus 3. So A and B, you see they are on the X-axis. That means those are X-intercepts of graph F. So that means if we want X-intercept, we let Y be equals to 0. So 0 is equals to X squared minus 2X minus 3. Then we need to solve for X. How do we solve for X? We factorize. So I'm assuming where everyone is able to factorize. So the factors for this, it's gonna be 3 and 1 minus 3 plus 1. X is minus 1 or X is equals to 3. If you got lost somewhere, please don't be afraid to ask a question. So you can ask, then we correct it while we're still here, okay? So that means A will take the minus 1. That means A will be minus 1. Remember, Y is 0, so minus 1 and 0. B is 3 and 0. Those are the coordinates of B. Then question 6.3. 6.3, they say determine the range of F. Range of F. Anyone who wants to try? What is the range of F? Anybody? Avakole? Okay, all right, let's do that. So you see the range will be actually where your graph turns, right? Mara, we don't know the value of this, where this graph turns. That means we need to get the turning point for this graph. And what is the turning point? The turning point will be your X, the value of your axis of symmetry, and the Y value of that. So axis of symmetry for a parabola is X is equal to minus B over 2A. What is the value of B? This is your graph. So minus the value of B is negative 2 over 2A is 1. That means we have 2 over 2, which is 1. And then if X is 1, what will be the Y? So we have Y is X squared minus 2X minus 3. We put the 1 here, minus 3. That is going to give us negative 4. So that means the turning point is 1 and minus 4. So that means here we have minus 4. Therefore, if we have minus 4, the range will be Y is an element of So we're starting from the negative side of y, we're going up. Where does our graph start? Where is the minimum value of our graph? It's -4. So that means we have -4. And where does the graph end? You see the graph doesn't end. This graph can just continue. So it up to infinity. Infinity is going to be an open bracket because there is no inclusive value. -4 is included. So we have a square bracket. So that is the range. Okay, I'm gonna move this thing this side and just see something. Okay, move this here, move it here. Okay, hopefully you guys will see when I'm writing on the far right. Okay, so 6.4. If you guys can't see where I'm writing, please just let me know. So 6.4 now, they say if Mn is 6 units. Okay, then the first part of the question, 6.4.1, determine the length of OT. Where is OT? Here is OT. Okay, determine the length of OT. If T lies on the negative x-axis, show all your working. Okay, so they tell you Mn is 6. Let's see where is Mn? Mn is this, right? Okay, so then they want what? The length of OT. So they want OT. Okay, so Mn is the y value, is actually the length, which means the point here minus this lowest point here. Okay, but okay, so Mn is the maximum value of f, graph f, minus the value of the minimum value of y, which is the y on graph G, right? So this Mn, they said, is 6 units. Okay, so this is Mn. That's what it is. This y minus this y value minus this y value. Okay, and what is the y value? We know that Gx, let me start with f. We know that fx is equals to, you guys, you can see, right? X squared minus 2x minus 3. Gx is x plus 1. So that means your Mn is going to be equals to, remember f at x is the same as y. G at x is the same as y here. So because we don't know the exact values, we use the equation as the y values. So x squared minus 2x minus 3 minus the y of g, which is x plus 1. But they gave us this value is 6. So x squared minus 2x minus 3 minus x minus 1 is going to give us 6. So we need to solve the x value here. X squared minus 3x minus 4 minus 6 is 0. X squared minus 3x minus 10 is 0. So we factorize here. 5 and 2 minus and plus. So that means x is minus 2 or x is 5. And you see the t, they said, is a negative value, is on the negative side. So that means this value here is minus 2. Then now we want the length of OT. The length of OT is from the origin to point T. So that means it's either, we can just say, if you see it straight away, OT is going to be 2 units. If you want me to explain it the longer way, OT now, in just like the y, is the x at 0 on the far right minus the x on your right minus the x on your left. That's how you get that length. X on your right is 0. X on your right is minus 2, which gives you 2 units. That's how you get that. Okay, so that is the value for OT. That's how you get that. Then the second part of the question now, they say now, Siabonga, you are not muted. Please mute. Then they say, hence, write down the coordinates of n. So we've got t. So they say now we must write down the coordinates of n. If this is -2, that means already our n, x value for n is -2. We just need to find the y value for that. And can you see n is on graph G? That means we can take graph G and substitute the x value that we know to get its y value. So I'm gonna squeeze it somewhere here. That's 6.4.2. We know gx is x plus 1, and then we know x is -2. So g at -2, or you can say y, it's -2 plus 1. That means your y value is -1. Just not to confuse some of you guys. So if y is x plus 1, I know x is -2 plus 1. Therefore, that y is going to give me -1. Therefore, coordinates of n is -2 and -1. Okay, so that's that. Then, okay, yeah, that's 6.4. Then 6.5, they say, determine the equation of the tangent to f. The equation of a tangent to f drawn parallel to G. So the equation of a tangent, which color am I gonna use? Let me use red. Use purple. The equation of a tangent to f, it must be parallel to G. So this is G. So that means that parallel line, it's something like this. That parallel line. They said it's parallel to G. And we said if lines are parallel, that means they will have the same gradient. So m of this tangent will be equals to the m of G because they are parallel. Okay, so that's already, you just know that. Okay, so those m's are the same. And then also remember from your calculus that a gradient is the same as it's a derivative at that point. So a gradient at this point is actually a derivative of this equation f, or the graph f at x. So a gradient derivative is a gradient of the function. So that means that, let me just clean here because now it's becoming chaotic. Okay. Okay, so a gradient is a derivative of a function. Okay, so a derivative is a gradient of that function, right? It doesn't matter whether you say a gradient or a derivative. So that's that. So that means the gradient of the tangent is actually the derivative. And what is this function? We said f at x, it was given is x squared minus 2x minus 3. So derivative here, we said is going to be 2x squared, 2x minus 2, right? If you don't know how to do a derivative, we can talk after this. So which is equals to, but we know the gradient for this line we said is actually equals to the gradient for G, and the gradient for G is 1. So that means this is equals to 1. Then we solve for x. 1 plus 2, that means x is 3 over 2. X is 3 over 2. What was the question? Determine the equation of this line, okay? So if x is that, then let's get the y. Let's get the y value, because we only have the gradient for this line. So that means now that line I get is mx plus c. We know the gradient for this line is 1. That means, this is c. So that means we have x plus c. We need c. But for us to get c, we need to have at least one coordinate that we can substitute in the equation to get the complete equation of the line. So at the moment, we only have x value. Let's get the y value that goes with this. So if x is 3 over 2, y will be, remember this is on the parabolic graph. So y will be 3 over 2 squared minus 2 into 3 over 2 minus 3. I substitute this into the equation of the parabola. Sorry. Then I have 9 over 4 minus 3 minus 3. 9 over 4 minus 6. Let's see. 9 over 4 minus 6, which is 3 and 3 over 4. This is the same as 15 over 4. Okay. So then that means this point here is, sorry, 3 over 2 and 15 over 4. So now I can take that and substitute here to get the value of C for the equation. So Y is 15 over 4, X is 3 over 2 plus C. Then the value of C will be 15 over 4 minus 3 over 2. Then let's see how much that is. So minus 3 over 2. Five and 1 over 4, which is 21 over 4. Okay, so that's the C value. Therefore, that equation of a tangent is going to be X plus 15 over 4. It's a negative. Let's see. Wait. Let me see. What did I do? Where did I lose the negative? The Y value, X is that. And then what is X? What is this? 9 over 4 minus 6. How much is that? 9 over 4 minus 6. This is a negative value. This 15 over 4 is a negative value. So this is minus 15. Anyone who got lost somewhere, please don't be shy to ask. Everyone is fine. Okay, I assume you guys are fine, but I doubt it. If you guys are fine, then that's good.
Good.
I'm struggling to hear you. I assume that's Andy, so. TD.
Yes, I'm good, ma'am. I'm good.
Oh, all right, okay. Okay, then the last question here, they ask, for which values of K will the function F and H? So let me just clean here. They say for which values of K, ne? For which values of K will F at X and H at X, which is X plus K, not intersect? Okay, so for which values of K will F at X and this new equation H at X not intersect, right? So can you see the tangent? We just answered we have the equation of the tangent, which was Y is X minus 15 over 4, right? So they're asking you now, which other line will not intersect with this graph? You see, if I were to draw a line here, it's going to intersect with the graph. There, it's going to intersect with the graph. If I go anywhere above this point, it's going to intersect with the graph. The only point where any equation or any line is not going to intersect with the graph is below this point, but parallel, obvious. So it's actually where below this, where K is less than this value. So K must be less than negative 15 or negative, this is 21, not 15. This equation is 21. negative 21/4. So your K must be anywhere less than this, because anywhere else, if you go above that gradient, that tangent line, that line will intersect the graph. They want anywhere where the line is not going to intersect. So the only that is not going to intersect is below this point, which is where K is less than minus 21/4. Okay, so if you guys, you don't have any questions, then we can move to trigonometry. Trigonometry, it takes a bit long. So then we can, I think we can go there now. Okay. Get my notes. Trigonometry. Mm-mm. 20 past 2. I'll tell you. Okay, so let's look at trigonometry. Okay, so just some basic things from trigonometry, just in case you are not updated with your basics. So if we've got this will be your X, this is X and Y, this will be your Y, this is your R, this is a 90 degrees, this is a theta, and then here, your sine theta is opposite over adjacent, over hypotenuse. If I make a mistake, guys, please correct me, don't let me carry on, because I do make lots of mistakes. This is adjacent over hypotenuse, X over R. This is opposite over adjacent, Y over X. And then the other ones, trigonometric identities. Sine squared theta plus cos squared theta is equals to 1. And then tan theta is equals to sine theta over cos theta. Okay. And then the other ones, you've got your special angles. So your special angles in trigonometry, you've got 0, 30, 45, 60, 90, 180, 270, 360. Those are the special angles. So most of the time when they ask you to simplify, you need to try and write your equation or that function in terms of those special angles, not 25 or 37, because we don't have those. If you've got those ones, they must be able to cancel out with another one. So that's the only way. If you can't turn that thing into a special angle, somewhere it must be able to cancel out with the other one. So you must make them the same. If maybe let's say you had what can I use, 27, then somewhere you had 27 and 63. So you must choose which one you're going to use. You must keep one. If you keep 27, you must change 63 into 27. Yeah, but we'll see that one when we when we get there. So then our special angles, we've got here, how you get them. Let's say this is 30, this is 60. This one's how I do it. Sine 30, everyone knows sine 30 is half, 1/2. So this is what I use. So sine is opposite, so 1/2, because sine 30 is 1/2. That means it's your opposite over R. What's this? Hypotenuse. So 1/2, that's 2. Then when you add with your Pythagoras, this is going to be square root of 3. So that's how you get that, because this is not going to be given to you in the exam. So, but always, please, when you write your exam, in your scribbling book, put these things there. You're going to need them. Then another one is the 1 year 45. So you have 45 and 45. This is 90. You know, tan 45, if you check it on your calculator, it's 1. So tan is 1/1, which is y over x. That means y is 1, x is 1. Then if you add with your Pythagoras, that's going to give you square root of 2. So you have this. Once you've put this down like this, then they tell you to simplify without using a calculator. You need these two triangles, this information here. This is how I memorize them. Sine 30 is half, 1/2. You plug it here, you get the other value. Tan 45 is 1/1, which is a x/y. You put them there, you calculate the other value, which is the value of r. Okay, so that's that part. So then if Sine 45, it will be 1/√2. Cos 45, it will be 1/√2. Tan 45, we know is 1. Okay. Then Sine 30, we said is 1/2. Cos 30, it will be √3/2. Tan 30, it will be 1/3. Okay. Sine 60, if you check on the triangle, √3/2. Cos 60, it will be, wait. Yeah, 1/2. Tan 60, it will be √3/1, which is just √3. Okay, so that's that. Then we've got Sine 0 is 0. Cos 0 is 1. Tan 0 is 1. Sine 90 is 1. Cos 90 is 0. Tan 90 is undefined. And then Sine 180 is 0. Cos 180 is 1. Tan 180, where is that one? Is 0. This is -1. Cos 180 is -1, okay? Then Sine 270, it's -1. Cos 270 is 0. Tan 270 is undefined. Then Sine 360 is 0. Cos 360 is 1. Tan 360 is 0. Okay. So that's that part. Then let's look at another thing. You've got 0, 90, 180, 270, 360, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 360 minus theta. Okay, you know the cast. All angles are positive, sine is positive this side, tangent is positive, and then cos is positive this side. Okay, then from there, let's start with the 180. Sine 180 minus theta, it's a cos. It's a sine theta. Okay, it's a sine theta, and then it's positive because 180 minus theta is in there. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So 180 minus theta is in the fourth quadrant, and a sine is positive in the second. 180 minus theta is in the second quadrant, and a sine function is positive in the second quadrant. That's why this becomes positive. Cos 180 minus theta, it's a negative cos theta because a cosine is not positive in that quadrant. Tan 180 minus theta is a negative because that tan is not positive there. Then let's go to the next one. 180, third quadrant. Sine, just do them in order. Sine 180 plus theta is negative sine theta because a sine is not positive in there. Cos 180 plus theta is a negative cos because a cos is not positive. Tan 180 plus theta is a positive tan because a tan is a positive in the third quadrant. Then let's go to 360. Sine 360 minus theta is negative sine theta because sine is negative in the fourth quadrant. Cos 360 minus theta is a positive because a cosine is positive in there. Tan 360 minus theta is a negative because a tan is negative in that quadrant. Okay, so that is that part. Then there is another point, a negative. Okay, when you have negative angles. Okay, So I'm going to use a blue pen. So if you go, remember we were going clockwise direction. We're starting from 0 going clockwise. I mean, going anti-clockwise. Now, if you go clockwise, okay, it becomes negative theta. Okay, so sine negative theta, it becomes a sine theta, but it's a negative because here in this is a fourth quadrant. In the fourth quadrant, a sine is negative. Cos negative theta, it becomes a positive because in this quadrant, a cosine is positive. Tan negative theta, it becomes negative because a tan is negative in there. Okay, then let's come this side in the third quadrant. So now we have minus 180 minus 180, negative 180 plus theta. Okay, so sine minus 180 plus theta, it's a sine theta, but it's negative because a sine is negative in the third quadrant. Cos negative 180 plus theta is a negative because a cos is negative in there. 10 negative 180 plus theta is positive because a tan is positive there. Then let's go to the second quadrant. That will be negative 180 minus theta. So sine minus 180 minus theta, it becomes a positive because a sine is positive there. Then cos negative 180 minus theta is a negative because a cosine is negative there. 10 negative 180 minus theta, it becomes a negative because a 10 is negative there. Okay, so that is that. Then the last part here, we've got your cofunctions where a sine becomes a cosine. So that's when you've got your 90 angle, 90 minus theta, 90 plus theta. Okay, so sine 90 minus theta, it becomes cos theta. It's positive because a sine in the first quadrant is positive. All angles in the, all functions in the first quadrant are positive. So cos 90 minus theta, sorry, it becomes negative, positive also, positive sine theta because all functions are positive. Then let's go to 90 plus. Sine 90 plus theta, it's a positive cos because sine in the second quadrant is positive. Cos 90 plus theta is a negative sine because a cosine in the second quadrant is negative. Okay, so that is that. That covers your first trigonometry, which is the before you go to the other one for the rules. So that is the first one. Any questions? Okay, silent, then I assume no questions. Let's move on. Then let's go to the other chapter. You've got the area rule. Okay, so the area rule, you've got your triangles here. A, B, C, A, B, C, A, B, C, A, B, C. Here we know angle A. A, B, C, this is B, A, B, C. Here we know angle B, here we know angle C. B, A. Okay, so area rule, area of triangle ABC in this first triangle will be half BC cos A, because we know angle A. They say the area rule, you can use the area rule if you are given two sides and an included angle. An included angle, it means the angle where you know these two sides. So this angle here is included because you know this side, you know this side. So you know two sides and an included angle. It can't be this angle because you don't know this side. You only know these two sides here. So that means the included angle value is this one here. So angle A, if you were given a C and B and angle A, you can use the area rule, okay? So that's the formula. Area of triangle ABC will be half base, half BC times cos A. So give the two sides and that angle, okay? So angle sides that are not included, you will have its angle there, okay? Then for this one, that area of triangle ABC, you will have a half AB, the included angle is B. Here, that area of triangle ABC will be half AB cos C. I'm not going to prove this ones because they will take time. We don't have enough time to be able to do the proofs. Okay, so that's the area rule. You only use it when you are given two sides and an included angle between the two sides that are given. Okay, then sine rule. Okay, you have this triangle here, ABC. You have this one, that one. Okay, so with the sine rule, you have A over sine A will be equals to B over sine B. You will have C over, someone is not muted and they are busy talking. Please mute. Over sine C, okay? These are angles, even though I don't put the thing. So, or you can write it. Okay, which is sine B over B or sine C over C, okay? So here, it's advisable you use the side or your unknown, always start with it. If maybe you were asked to solve for side A, please put your side A at the top. Don't put the angle at the top. Only if you don't know the angle, you put it at the top. It makes life easier. Otherwise, you're going to cross multiply so many times. So the side that you don't know is advisable to put it at the top. Okay. So that is the sine. And then the sine rule, you use it if you are given two sides and the angle that is not between the given side. So unlike the area here, you are given two sides and the other angle. It doesn't have to be the included angle, okay? And then, or you are given two angles and a side, okay? So that's when you use your sine rule. Then cosine rule. So cosine rule, you've got these triangles. ABC, this is BCA, 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 okay? So they say a cosine rule, you can only use it if you have a triangle where you are given all three sides. So a cosine rule, if you are given all three sides, you can use a cosine. Or if you are given two sides and an included angle, you can use a cosine rule. So remember, when you're given two sides and included angle, is you use it to get the area, or you use the cosine rule to get the unknown side or the angle, okay? So a cosine, only if you are given all the sides or you are given two sides and an included angle, okay? Then they say if a side of a triangle has a square root in it, the cosine rule is the most likely rule to use. So if a given side of a triangle has a square root in it, the cosine rule is the most likely to be used. But let's look at the cosine rule. So you will have a squared is equals to b squared plus c squared. So if you use a, you're not going to have a here. Minus 2 bc cos a. So if you have a, you're going to have a here. Same, b squared will be, so here we use the a, and then here we're using b, here using c. It's going to be a squared plus b squared minus 2ab cos a. This is c. So a squared plus c squared minus 2ac cos b. Then c squared will be a squared plus b squared minus 2ab cos c. Okay, so that is your cosine rule. Okay, then there is something called a bearing angle. So a bearing angle is just a way of measuring direction of one object from another. So a bearing, when they say a bearing of something is 65, it just means they're measuring it from the north. So you are measuring that from the north. Let's say they said 65 degrees. So they will be saying a bearing angle of 65. You are measuring it from the north. If it's a bearing angle of 135, you will go 90 and then that will be your bearing angle. That's what the bearing angle means, okay? Then let's go to compound angles. This is where this is where grade 12 additional work start from for grade 12. So compound angles, you've got cos A minus B, which is cos A cos B plus. So check with the cos, you have a change of sign. Then sine A, sine B. Cos A plus B, you have cos A, cos B. The sign will change, it becomes a minus. So here you will have a change of sign, right? But with the sine function, the sign doesn't change. You will have sine A cos B minus cos A sine B. Sine A plus B, you will have sine A cos B, sign doesn't change, cos A sine B. So here, no sign change. Okay. Then that is a compound angle. Then we've got double angle. Double angles, we've got cos 2A, which is cos squared A minus sine squared A. Okay. And then remember the trigonometric identities, that sine squared A plus cos squared A is equals to 1. Okay. That means sine squared A can be 1 minus cos squared A. Cos squared A can be 1 minus sine squared A. Okay, so I can replace this here. So if I replace sine squared here, so I will have cos squared A minus 1 minus cos squared A. This gives me cos squared A minus 1 plus cos squared A. That gives me 2 cos squared A minus 1. So a cos 2A can be cos squared A minus sine squared A, or it can be 2 cos squared A minus 1. Or we can take cos and replace it here. So we had cos squared A being cos squared A minus sine squared A. If we use cos, that means, this is cos 2A. Okay, this will be cos is 1 minus sine squared A minus this sine squared A that was here. That means we have 1 minus 2 sine squared A. Okay, so your cos 2A, you can use it as a cos squared A minus sine squared A, or you can use it as 2 cos squared A minus 1, or you can use it as 1 minus 2 sine squared A. So remember that. And when you use this, how do you know when to use this and when to use that one, or when to use that one? A note is, an advice is, if the identity you are solving contains cos 2A, it is useful to choose option that eliminates the constant. Let's look at an example on that. Let's say you are given 1 plus cos 2A. They say simplify. You see, there's a cos 2A. Now, which one are you using? This, or that? They say use the one. It's useful to choose the option that will eliminate the constant. This is a constant here. So let's look at the option that when we use is gonna end up canceling this constant, which is 1. Okay, so here we have 1 minus 2 sine squared A. If we put it here, we're gonna end up with a 2. It's not gonna cancel out the 1. if we use 2 cos squared A minus 1, can you see this is going to cancel out? So this is 1 plus 2 cos squared A minus 1, which is giving us 1 plus 2 cos squared A minus 1. Can you see this 1 and minus 1 cancel out? We have 2 cos squared A. So that's when you use that one. The same way, if you are given cos 2A minus 1. So if we look at this one, if I take this one and use it here, you see I'm going to end up with minus, with plus 2 or minus 2. It's not going to cancel out. But if I use this one now, cos 2A, now I use it as 1 minus 2 sine squared A, then minus 1. You see this and that cancel out. I'm left with 2 sine squared A. So that's how you know when to use this or that. Okay, so that's when you use that. This one is maybe if you've got factors where you find you are maybe is a fraction, you have cos A minus sine A, or you have cos A plus sine A. You see, these are the factors of this. So if we are given an expression which has one of these, then you know you use this one. If you had to cos 2A, you can use this. Then you know one of those factors will cancel out, if not both of them. Okay, so that is all about the double and the compound angles. Okay, let's move right along. Okay, then we've got trigonometric equations. Trigonometric equations. Okay, this I'm just gonna rewrite them. They're not given to you in the formula, but you also just need to write them down. Then I don't know if it carries 5 marks or 3 marks. You just need to put them down. You get used to this. Then that's all you need. When they ask you to get a general solution, you just factorize, solve for X or solve for theta, then you apply this rule. So here, if sine theta is equals to M, and M is less or equals to 1 or greater or equals to minus 1, then theta will be reference angle plus 360 degrees K, or theta will be 180 minus reference angle plus 360 degrees K. And this K is an element of integers. Okay, if cos theta is M, and that M is between 1 and minus 1, then your theta will be plus or minus your reference angle plus 360K, where K is an element of integers. Okay, if tan theta is M and M is an element of real numbers, then your theta is going to be your reference angle plus 180 degree K, where K is an element of integers. Okay, and how you get the reference angle? The reference angle, you use your calculator, whether you use the second function or you use the shift, then that sine of that M. So shift sine of that, or shift cos of that M. Okay, or shift tangent of that M. So let's say I had tan theta is equals to 3. So my reference angle will be a shift tan 3, which is going to give me a certain angle. So second function tan 3, which is giving me 71.57. This is my reference angle. Then that means therefore theta is, on the tangent, theta is reference angle plus 180 degrees K, and K is the element of integers. That means my theta is 71.57 plus 180 degrees K. Don't forget to say this, K is an element of that. That's it. When they ask you to determine the general solution of an equation, that's what you do. So if it's a tan, this is how the reference angle is. If it's a cos, this is how it looks. If it's a sine, this is how it looks. That's all you do. But normally they will give you an equation that is complicated, then you need to factorize it, factorize it, then solve for that equation. Then once you have it in this form where you have your tan theta is something, or your cos theta is certain value, or your sin theta is certain value, then you apply this. Okay, so that is it on trigonometry. So now we can go to the question papers. Okay, let's start with this one. Okay, so let's do this one. Are you guys able to do this? Can I give you guys a 5 or 10 minutes to do this? Can you guys try that? Who can do this? Who can do it? It's just the 5 of us, so you guys can try this. You don't want to. Okay, let's read the question anyway.
All of us.
Sorry?
All of us.
Yes. You do it, then I'll give you guys 5-10 minutes, then you give me your answers.
Okay.
So then 3 o'clock, you guys should give me the answers. You give me whatever you found. Then we can, if you guys got all of them right, then we move on. If not, then we can discuss them. Please try that. Let me charge my pen in the meantime. Are you guys winning?
I'm not managing to see the question anymore.
Is it? What is showing now on the screen?
It's showing the document files
Okay.
and the images, but
Table.
no specific images showing.
Okay, let's see. Can you see it now?
Yes, I can see it.
Okay. So all of you guys, you were not doing anything. Okay, 2 more minutes, then we'll just do it together.
Sorry, ma'am.
Yes?
Hello. I'm lost. Which question 5 we're doing? The one on the
Question?
screen.
The one with the... it's question 5, CAPS grade 11.
The one that says calculate the value of K.
No. Okay, it's fine. Let's. You can't see the screen.
Oh, we're doing the one on the screen. Oh, It's now showing. It's now showing. Thank you. I'll do it now first.
Okay, let's do it together to save time because we still have more complicated ones to do. Ne? Let's do it together. Okay, so you are given this. This is theta. This point is this point R. Is this K or R? Okay, this is P. Okay, one. Then you've got K, you've got 1 here, point O. Let me just go back and see what is this again. K, not R. Okay. You can see my screen, right? Okay, so they say in the diagram, P, which is K and 1, is a point in the second quadrant. and is root 5 units from the origin. So that means from here to point K, it's root 5. That means our R or hypotenuse is root 5. R is a point, K is the point on the positive axis. So this is point K. And then obtuse ROP is the theta. So KOP or R. Why am I saying R here? KOP is the theta. Then 5.1.1, they ask you to calculate the value of K. So they want the value of K, okay? So if this is theta, we have the opposite and we have the hypotenuse. So you see, we can use the sine theta, which is opposite over hypotenuse. Opposite is 1, hypotenuse is 5. So that means our theta will be the second function sine of 1 over 5, which is 1 over root 5, 1 over root 5, no, root 5, 26.57 degrees, okay? Can you see that 26.57 degrees is actually the angle this side, right? This is 26.57. Okay, then that is theta. What were we looking for? The value of K. Okay, why did I go that way? So for us to get K, you just use the Pythagoras. So R squared is X squared plus Y squared. Our R is root 5. Our X is K. Our Y is 1. So that means 5 minus 1 is K squared, which is 4. Then we square root that. That means our K is plus or minus 2. But you see our K is in the negative side of the X. So that means K is negative 2. Okay. Then 5.1.2. They ask you, without using a calculator, calculate the value of tan theta. So tan theta we know is opposite, which is the Y value over X adjacent. What is our Y? Our Y is 1, and then our X is K, which is minus 2. Then 5.1.3, they say, oh, okay, it's the part B of this, of 5.1.2. Without using a calculator, get the value of cos 180 plus theta. If you remember from the notes we did earlier, cos 180 plus theta is a negative cos because a cosine is negative in that third quadrant. So then a cos theta is K over hypotenuse, which is root 5, and our K we know is minus 2. That means we have 2 over root 5. Okay. Then number C, get the value of sine theta plus 60 in the form of A plus B over root 20. Okay, so you see this sine theta plus 60, you see this is a compound. Let me put this on the bottom. So this is a compound angle, which we can write it as sine theta cos 60 degrees. The sign doesn't change. What is it? Cos theta sine 60 degrees. Okay. And what is sine theta? We said sine theta is 1 over root 5. Cos 60, remember cos 60 from here, 30, 60. We said this is 1 over 2, then this is root 3. So cos 60 then becomes 1 over 2. Ne? This is root 5 plus cos theta from here. Cos theta is from this side. A cos theta is K over root 5, which is K is minus 2 over root 5. Just put it in bracket. Times sine 60 is root 3 over 2. This is 1 over 2 root 5 minus 2 root 3 over 2 root 5. This is 5. So then we have a denominator of common denominator of 2 root 5, 1 minus 2 root 3. Someone is not muted. Okay, so they said we must write it in this form, right? So you must have a and b and root 20 underneath. So if you look at 2 root 5 and root 20, root 20, remember, is the same as 4 times 5, which is root 4 times root 5, and root 4 is 2. So you see then here, 2 root 5 is the same as root 20. Therefore, we have 1 minus 2 root 3 over root 20, because they wanted us to write it in this form. So that is that one. Then 5.1.3. Okay, let me just clear here. I know k is minus 2. So I might need that information. So let's see. Okay, 5.1.3. Use a calculator to calculate the value of tan 2 theta minus 40 degrees. Correct to 1 decimal place. Okay, so you know that theta, remember I calculated theta. So theta was 26.57, right? Actually, this was 26.57, but the theta will be minus, or you can say, you know, tan theta is, what was tan theta? 1 over minus 2, right? Then what is theta? So second function tan of negative 0.5. Second function tan of minus 0.5. This is negative 26.57. Okay, so it's a negative angle. That means this angle is this side, not that one. For us to get this, we add 180 to that. So plus 180 is gonna give us the theta. Okay, so that means our theta will be this plus 180, which is 153.43 degrees. That is theta. Then for us to calculate this using a calculator, theta is 153.43 minus 40. That will give us times 2 minus 40, then tangent of that. That is giving us 18.29. Let me just see if that's correct. Yeah, 18.3 degrees. Okay, so that is that. Okay, then 5.2. Okay, so let's look at 5.2. 5.2, prove the following identity. Okay, I need the whole space. They want us to prove. So you are given cos x plus sine x over cos x minus sine x minus cos x minus sine x over cos x plus sine x is equals to 2 tan 2x. Okay, so they want us to prove. So you can prove the left hand side, it might lead you to the right hand side. Sometimes you can prove the left hand side, and then if it doesn't get you directly to the right hand side, you can take the simplify the right hand side as well. But the idea is at the end for you to have the left hand side being equals to the right hand side. Okay, so you see the complicated one that we need to simplify is the left hand side. So we're going to start with the left hand side. So left hand side is cos x plus sine x over cos x minus sine x minus cos x minus sine x over this plus that. And then the lowest common denominator here, that means we're gonna have we're gonna multiply both of them. And cos x plus sine x, okay? Then that means here, this is cos x plus sine x, we're just gonna put it here. But when we divide this by that, it's gonna have a remainder of cos x plus sine x, okay? Then we bring this one down, minus cos x minus sine x. Don't forget to put it in the bracket so that you still have your signs correctly. Then if we divide this whole thing by that, is gonna give us a cos x plus sine x. Okay, guys, if I make a mistake, please correct me because we will have to come back from when we've done a lot of work. Okay, so now we can simplify these ones. I'm gonna multiply the brackets, so I'm gonna multiply this and that, come back, multiply the sign in that one. Okay, cos x squared, cos squared x plus cos x sine x plus sine x. Jeez, what am I writing? Cos squared x, cos x sine x plus sine x cos x plus sine squared x. Then we come this side, I have a minus, I still leave it outside. Then I have cos squared x plus cos x sine x minus sine x cos x, okay? All over cos x. Let's simplify it also. That is cos squared x plus cos x sine x minus sine x cos x minus sine squared x. Can you see this and this cancels out? And then let's see at the top what cancels out. Okay, I still need to remove the brackets. So at the top I have cos squared x. This and this are the same, so I have plus 2 sine x cos x. If I rearrange them properly, if you don't see that, please let me know. Sine squared x minus cos squared x minus cos x sine x plus, actually these two cancels out before I go far with them. Can you see this and that? They will cancel out. So that means I only have minus cos squared x there. Okay, then this will be over. If you can't see, please let me know. Cos squared x minus sine squared x, because these two have cancelled out. Okay, so then now, can you see this and that cancels out? Then I am left with, I can take out a common factor just to save space because I don't have space. I'll somehow take out the common factor here. So you see sine x and sine x are common factor. So at the numerator, I have sine x into 2 cos x plus sine x. You see at the bottom, I can factorize that. That is a binomial, a perfect square binomial, cos x minus sine x into cos x plus sine x, okay? So then you can see wait, is this correct? What did I do here? Oh, okay, I didn't have to factorize this. Okay, then remember your cos 2x is the same as cos squared x minus sine squared x. Can you see this is what we have here? That means then my denominator will be cos 2x. Okay, so I have cos 2x at the bottom. Then what do I have here at the top? What did I do? Did I make a mistake somewhere? This and this are plus. That cancelled out. What did I do here? Let me just see on my calculation here. This is true. Oh, no, this was not done. The top one. You guys, you don't help me here. I've made a mistake somewhere here. So this one looks fine. This one looks fine. Then this one, we have cos squared x. We've got plus cos x sine x. We've got minus cos x sine x. Then there's something missing here, plus sine squared x. That part is missing. Okay, so when this and this canceled out, I still have sine squared x. So here I still have plus sine squared x. Then, is it going to be a plus? It's going to be a minus. Let me remove this so I see properly. So when this sign comes out of the bracket, it becomes minus. Okay, let's just start the step. Okay, let's look properly now. So we've got cos squared x will cancel out. This will cancel with that. This will cancel with this. Now I am left with 2 sine x cos x over cos squared x minus sine squared x. Okay. Then, yes, Snetemba, you raised your hand. You can unmute, then you can talk. Okay. Then remember, cos 2x we said is cos squared x minus sine squared x. And then sine 2x is equals to 2 sine x cos x. Oh, we forgot to put this part when we're doing the double angles. That's the double angle for the sine. So can you see now this, the numerator is a sine 2x and the denominator is a cos 2x. And a sine over cos is a tangent. So we have tan 2x. And this, there's a 2 here, see? So 2 tan 2x. This is the right-hand side. Okay, so that is, we have proven that. Okay, so that is that. If anyone has a question, please do so. Then there's 5.3. 5.3, they say evaluate without using a calculator the sum of cos squared A, where A is 38 degrees up until 52 degrees. Okay. So this is just one of those questions where they are making sure you don't get 100%. It's a bit complicated. So if you remember your series, okay, so you will have, this is gonna become cos squared, your A, you start with 38 plus cos squared 39 plus cos squared 40 plus cos squared . Okay, this is sending to someone else. The message that was sent there. Then cos squared 41 and then cos squared 43 plus cos squared 44 plus cos squared 45 plus it goes all the way. Let's say cos squared, maybe let's say 49 plus cos squared 50 plus cos squared 51 plus cos squared 52. Okay. So this is what this is a sigma notation implies. This is what you have. So you are adding all these values from 38 all the way up until the last one, which is cos squared 52. Okay, but we need to relate this to your trigonometric functions. Okay, so cos squared 45, we know, change the color, cos squared 45, that's a special angle for our trigonometry. So we can use that. We can leave this one here. Then the other ones, we can try to change them so that we can pair them. So the idea here is for us to have compound angles. So to have either have cos A plus B, or have cos A minus B, or sine A plus B, sine A minus B. Okay. But for us to have those, then we need to have similar angles here. So we can try to change these angles at the after 45 here. So let's see if we try that. Let's see what's going to happen. Okay, so we will leave the first ones like this. Plus cos squared 39, plus cos squared 40, plus cos squared 41. I'll leave it here. Then cos squared 45. Then 38 minus 90 is 52. Then I've got, just hold on, I wrote it somewhere. So where did I put it? Okay, so then we can transform these ones from after 46. So after 46, remember the co-functions were cos 90 minus theta became a positive sine theta, and cos 90 plus it became a negative sine theta. Ne? So we can change this ones here after 45. So let's say I had put cos 46 there. So 46 will be, it's the same as, cos squared 46 is the same as 90 minus, what's this? What is 90 minus 46? Minus 44. Okay. Plus, then I'll go all the way. Okay, let's just add those. Cos squared 90 minus 45. Cos squared 90 minus 46. Plus cos squared 90 minus 47. Plus cos squared 90 minus 48, plus cos squared 90 minus 49, plus cos squared 90 minus 50. Okay, so let's see, this is 50. It was supposed to go down, not up. So I have 45, then 44 is 46. No, man, this was supposed to be 46. I'm going up here. So I'm going up. So this value should go down. So I'll have 44 here instead. 44, this is the same as 47 is the same as 90 minus 43. And then 48 is the same as 90 minus 42. So I was supposed to go down, not up. 90 minus 42, 90 minus 41, 90 minus 40. That is the 51. Then 51 will be 90 minus 40. What is 90 minus 51? 90 minus 51. 39. 39 plus cos squared 90 minus 38. That's the last one. 38 is goes with the 52. So what I did here is just rewrite this in terms of 90 minus 90 minus this last one after 45. Okay. Then once I do that, then I know this 90 minus, they are the same as, because 90 minus 46 is the same as sine squared 46. Sine squared 45 plus sine squared 44 plus sine squared 43, because 90 minus is a cofunction, plus sine squared 42 plus sine squared 41 plus sine squared 40 plus sine squared, let's put this down, sine squared 39 plus sine squared 38. Okay, so that's the same as that. Then now I can pair cos 38 and I can group them. So after you transform them, you can now group this. So I can now, I have cos squared 38 and plus cos squared 39. Then I can group this one with, so I have this, then plus, if I go all the way to 40, this is cos squared 45. And then from 45, I can group the sine squared. So after 45, where is what? This was 46. Oh, the blue ones. Okay, so I've got cos 45 and sine squared 45. And these two ones, you can already see they're gonna give you 1, because sine squared plus cos squared, it gives you 1. So that's that. Then plus, you can pair which ones here? You can pair this, so you can pair all the similar angles. So you've got 38, 39, you've got 38, 39 somewhere here. Here is 38, 39 somewhere here. So your cos and that, this and that, they're gonna give us the compound angle. Okay, so we're gonna pair that. Then at the end, when you pair cos squared 38 with a cos squared 38 here, not the red one, the blue ones. You pair cos squared 38 with the sine squared 38, it gives you 1. You pair cos squared 39 with the sine squared 39, it's gonna give you 1. You pair cos squared 40 with a sine squared 40, there must be sine squared 40 here, it's gonna give you 1. You pair cos squared 41 with a cos squared 40 with a sine squared 41, it's gonna give you 1. You pair cos squared 45 with a cos squared 45, it gives you 1. So at the end of the day, you're gonna have your 1 plus 1 plus 1. This is your, and the last one, it will also be 9. This is going to be your function. So your last one will be, wait, let's see which one doesn't pay. So the 8, we've got 41, 40, 43, 44, then 45, 40. This is not there. So you have 45. Which one is not there? 38 is there. So you have 1 and cos squared 45. Which one is the half? Cos squared 45. It doesn't pay. So this one, we don't have sine squared 45. Wait, let's see, there was another one, sine squared, this is 45. There's one thing that doesn't pay, and that one that doesn't pay, it's gonna be 1 over root 2. So this one, I think I can just do it nicely, the calculation nicely for you guys. If you want it, then I'll send it to you. But explaining it here, it becomes hard. It's too complicated. So this one, I can write it down nicely, then I can share it with you guys. So to save time, let's move on from this one. Let's see which other question we're gonna do. Okay, let me share the question paper again. Okay, we haven't done this one. I think we'll come back to it. Let me just see what else is here on the trigonometry. What is this? Okay, so we can do this one. Can you guys see on the screen?
Yes.
Okay. Right, so let's try this one, question 6. So without using a calculator, determine the following in terms of sine 36. Let me just go there on where I wrote on my book, question 6. This one. Where is question 6? Okay, here. Right, so let me go back to the board. Okay. Question 6.1. Without using a calculator, determine the following in terms of sine 36. Okay. So 6.1.1 sine 324. Okay. So remember earlier when I was doing the theory on trig, so everything you need to write it, you need to try write it in terms of what are these? The special angles. What do they call them again? So in terms of those special angles. So, or in terms of what is given, this time around they've given you, they want you to write this in terms of sine 36. So we have to try to change this to have 36. So sine 36 is the same as, so I mean 324 is the same as if we minus 360 from this 324 from 360 is 36. That means actually 324 is actually 360 minus 36. So if you see, this is, I didn't do anything. I just rewrote the 324. What is my calculator doing now? Not my screen. So 360 minus 26, not 20, 36. So 324 is the same as 360 minus 36. Okay. And then sine 360 minus 36. Is it a positive sine 36 or a negative? It's just the two of us now, so you guys can just answer me on that. We can just discuss this. So Siyabonga or Sina, is it a positive sine 36 or a minus? Okay, it's a negative because remember this 0, 90, 180, 270, 360, and your cast. 360 minus is this side. So this is a negative sign, sine 36. Okay. So we have written it in that. So that's the answer. The next one is cos 72. We need to write it in terms of 36. So you know 72 is actually 2 times 36. And this is a double angle, okay, for a cosine. And what is the double angle for a cosine? It's cos squared. Actually, it's either you're going to say cos squared 36 minus sine squared 36, or you're going to write it because they want it in terms of sine, 1 minus 2 sine squared 36. That is the answer, okay? Then 6.1.3, they say prove this identity. So the identity is 1 minus tan theta over, this is tan squared theta, over 1 plus tan squared theta. Prove that this is equals to cos squared theta. So you see, we're gonna prove the left hand side, which is a 1 minus tan squared theta is the same as sine squared theta over cos squared theta. This is over 1 plus sine squared theta over cos squared theta. We have 1 minus sine squared theta over cos squared theta. I'll just put this division here. So I had, this is 1 over 1. What is the lowest common denominator here is cos theta. So I'm going to have 1 times cos theta plus sine squared theta times 1, which is 1 minus sine squared theta over, this is a squared, cos squared theta. You change the division to multiplication, sorry, and then you flip this. This is a cos squared underneath. Jeez. So we've got cos squared theta over cos squared theta plus sine squared theta. Okay. Then this will be 1. Then you can see this will cancel that 1. Then we have sine squared theta over cos squared theta plus sine squared theta. What did I do here? There's something I did. There's a mistake. There's a 1. I left out that 1 outside. 1 minus, okay? So there's that 1. So we have 1 minus sine squared theta. You see cos squared theta minus sine squared theta. Cos squared theta plus sine squared theta is 1. Remember the trigonometric identity. So this is 1. So we are left with 1 minus sine squared theta. And 1 minus sine squared theta from the very same trigonometric identity. So cos squared theta from here is 1 minus sine squared theta. That means here we've got cos squared theta, and you see this is your right-hand side. So that identity is proven. Okay, so that's that. Then 6.3. Use question 6.2 to determine the general solution. Let's undo, let's go back. So this was 6.2, right? So they say use this this question 6.2. This was 6.2. Use it to determine the general solution for this. 1 minus tan squared half x over 1 plus tan squared half x, which is equals to 1 over 4. Okay, can you see this is in this form, right? But instead of theta, it's half. Okay, it's half. So x, we can assume that x is it's theta, but instead of just being x, it's half instead, right? So that means we saw that this is cos 2 theta. So wherever we have theta, we're gonna have put half x. So this actually is cos squared half x, and they said this is equals to a quarter. Okay, then now we need to solve for x. So for us to solve for x, we're gonna square root this. So that means cos squared half x is equals to plus or minus 1 over 2. Not cos squared, just cos half x. Okay. Then remember those notes I wrote on general solution. So that means now our reference angle here is actually inverse of cos of plus or minus half, right? We get that reference angle. So a second function cos of negative 0.5. One of the angles is 180, and then inverse of cos of positive that. The other one is 60. Those are our reference angle. Then that means theta, but in this case, that theta is half x. Half x is the reference angle. Remember, for a cos, it's plus or minus that reference angle plus 360 degrees, where k, 360 degrees k, where k is an element of integers, right? So that means half x is equals to 120, right? Plus or minus 120 plus 360 degree k. Then that is half, but we want x at the end of the day. So in general, we want to solve for x. So we're going to multiply everything by 2. that means X is gonna be plus or minus 240 plus 720 degrees K. Don't forget to write K is an element of that. Then, or if RA is 60, that means half X is going to be plus or minus 60 plus or minus 60 plus 360 degrees K. We do the same thing. We want to solve for X, so we multiply everything by 2. That means our X value is plus or minus 120 degrees plus 720 degrees K, where K is element of integers. Okay, so that is that. Okay, then question 6.4. Okay. 6.4, they say, you are given that cos A minus B is equals to cos A cos B plus sine A sine B. Then they say, use this formula for cos A minus B to derive the formula for sine. So use this formula for cos A minus B to derive sine A minus B. Okay, so they want us to use this to derive that formula. Okay, so we know that sine A minus B is the same as cos 90 minus A minus B. Remember from the cofunctions. Okay, so that is that. Then, but we want to use cos A minus B. So for us to use cos A minus B, then let's try to rearrange this. This is 90 minus A plus B, right? So, but we want it to be in this form. So we need to have two angles. So we can have 90 minus A and then B there. Okay. So if it's B, you see it's a plus, but they want us to use a minus, not the plus one. We need to use this one. So we can use this. So instead of minus B there, so here we're gonna leave this thing as 90 minus A, then minus, we leave this B still in the brackets there. Okay. So you see now we have this as A, our A is in this case is 90 minus A, our B is negative B. Can you see that? So we have this in that form, because 90 minus A and then minus negative B. So now we can now follow this formula, because 90 minus A, our 90 is A, so that means we have cos 90 minus A cos negative B. We're following that formula, plus sine 90 minus A times sine negative B. Okay, 90 minus A, it becomes a positive sine A. Cos negative B, remember, negative is this side, and a cos is positive this side. So that means a cos negative becomes a positive cos. Plus 90 minus A is a positive, it's gonna be positive cos because they are all in the first quadrant. Time sine negative B is a negative sine because sine in this quadrant is negative. Therefore, we have sine A cos B minus cos A sine B. So that is the formula for sine A minus B. That's how it's proven. Okay, so that's that. And then this next 6.4.2. They say then, without using a calculator, show that sine x plus 64 cos x plus 379 plus sine x plus 19 cos x plus 64. Okay, show that this If no, it's not. 19 and 244. This is 244. 244. Show that this will be 1 over square root of 2. Okay. So we're gonna use that previous. We're gonna need to simplify this. So left hand side. So I'm simplified already. Sine x plus 65 is, okay, before I go there, okay, so I'm just gonna write this, sine x plus 64 cos x plus 379 plus, so I had said, if you've got angles that are not trigonometric special angles, it's either you need to match them. So if you look here, we've got 64, we've got 379, we've got 19, we've got 244. So if you look one of these, if you minus them from 360 or from 180, they must give you, they must be similar. So 64, I can relate it to 244, because if I say 360 minus 244, not that one, let's say 180. 180 plus 64 is going to give me 244. So that means I choose to keep 64 but change 244. So I'm going to change 244 to 64. I'm going to change 19 to 379 because 19 is the same as 360 plus 19. Okay. So then that means here I'm going to have a, what is this? Actually, I was supposed to change here. You can't use the angle that is above this. So here I'm going to change this one instead of the 19. Then I'll keep 19 this side. Then I'll keep the 64. I'll just change the bigger numbers. 379 is the same as 360 plus 19. Okay. Here I'm going to keep this one the way it is because now it's going to relate to this one. Then this one, I'm going to change it to, so that it relates to 64. So 244 is the same as 180 plus 64. Okay. Then I have sine x plus 64. I've got cos, something that I forgot to mention to you guys. So, okay. So every time if you add or minus 360 degrees, let's say you have a theta or x here, it does not change the sign of that function. So if you have sine theta plus 360, the answer will just remain sine theta. If you've got cos theta plus 360 or minus 360, it will remain positive. So whether you add or you minus 360, it does not change the sign of your function. So every time you add extras 360 or you minus it, it doesn't change it. So if you see here is the same as, I'm just going to write it here to save space. So here is the same as I'm having x plus 19 plus 360. So you see I have x plus 19, I'm adding 360. That means my function is just going to remain x plus cos x plus 19 because it will not change the sign, because whether you add or minus 360, it doesn't change your function, your trig function. So this is x plus 19. Then sine x plus 19 remains the same. Then here I have, this is x plus 64. This is the same as 180 plus x plus 64. So cos this, this is the same as cos 180 plus theta, and theta in this case is x plus 64. So this cos 180 plus theta, it always gives us cos negative because a cos is negative in this quadrant. This is where you have 180 plus theta. That means here I'm gonna have a negative cos x plus 64. Okay, so that's what I have. So I have sine x plus 64. I've got x plus 19, x plus. Okay, if you look at this, can you see this is a compound angle? So I have sine x plus 64, cos x plus 19, and then there's a negative. That means I have negative sine x plus 19, cos x plus 64. Can you see this is a compound angle and this is a sine? See, x plus 64, x plus 19, x plus 64, x plus 19. Sine, cos, sine, cos. This is a sine compound angle. So I have sine x plus 64 minus x plus 19. Okay. This is the, remember the one we just did. It was if sine A minus B is the same as sine A, cos B, I mean, minus cos A, sine B, I mean. If you look this at this and that, they are the same. The only difference is instead of A, we have x plus 64. Instead of B, we have x plus 9 plus 19. Wait, yeah, x plus 19 here. Okay, so that's that. Then now I have sine x plus 64 minus x minus 19. That is sine x and x cancel out. 64 minus 19 is 45. And sine 45 from those two triangles, sine 45 is √2 over 45, we said tan is 1 over 1, then here is √2. So sine is 1 over the hypotenuse. So that is your sine 45. And can you see this is the right-hand side? So that was proven. Okay, so that's that one. I see the time is gone, but let's do one more example that we didn't cover because we didn't cover everything. Let me just go to the screen. Let's do one more question that was not covered here. Let me go. Where are those things? Okay. Okay. This is what we didn't cover. So I will show you another one. Even the graphs we didn't cover though. The trigonometric graphs we did not cover. So which one do you guys want me to do? Do you guys want me to do this 2-dimension trigonometry, or you want me to do the graph, the trigonometric graphs, functions? So I've got this or this. So is this or this kind? So I didn't do. So you want trigonometric function, which are graphs, but with the trigonometric graphs, or should I do this 2D? Unmute and talk to me, please. Which one should I do? Because the time is gone.
2D, ma'am.
2D, okay. So on 2D, I've got this one. So we're gonna choose one. I've got this one is 6 marks. And then I've got, this is question 7. And then I've got this one, which is 8 marks. Which one? So it's this one and this one. He can choose.
That other question 7, ma'am, which is 8 marks.
This one, okay. So let's do this one.
Yes.
Let me just find it in my book. And AC, okay. So, okay, let's see this one. Let me just try to redraw this. Okay, my drawing is not the best, but yeah, you guys will see. This is 40. This is 70. This is 27. Yeah. This is, what is this? 8.6, is it written here or? Yeah. 8.6. So in the diagram, let me put the labels A, B, E, C. Okay. In the diagram, B, E, and D are points in the same horizontal plane. A, B, and D are points in the same horizontal plane. Ne? This is 3D. I don't know if you guys will see, but if I go here, where is it? I agree. You see the highlighted part, they are in the same plane. So that's more like the bottom of the, if we were to call this a box. Okay, so that is that. So B, E, and D are points in the same horizontal plane. A, B, and C, D are vertical poles. Steel cables AE and CE anchor the poles at E. Another steel cables connect A and C. CE is 8.6 meters. BE is 10 meters. This is 10. Angle AEB is 40 degrees. Angle AEC is 70. Angle CED is 27. Then they say calculate 7.1, the height of pole C. Height of pole CD. So we want the height of CD, okay? So let me check that 90 degrees if I put in the right place. That 90 degrees, no, it's not the way I've put it. I've put them wrongly, so let me correct that. So these 90s are not like this. These 90s are like this. Okay, so this is the 90 degree, okay? So if you look at triangle ECD, you see it's a right angle triangle. So that means we can use what is it? We can, if you have a right angle triangle, you can use your sine functions or you can use a Pythagoras. So in this case, we have given an angle and a side, so we can use a sine angle. So sine 27 degrees is CD over EC. So that means sine 27 degrees is equals to a CD over 8.6. Therefore, CD is 8.6 sine 27 degrees. So 8.6 sine 27 is 3.9. Therefore, CD is 3.9 meters. Just see if it's correct. Yeah. Okay. And then 7.2. Calculate the length of cable AE. Length of AE. Okay. Let's look, where is AE? AE is in triangle BAE. Okay. You see that triangle is also a right angle triangle. And we also have a given angle. We have one side. So we can use a cosine function. So cos 40 degrees is equals to BE over AE. That means cos 40 degrees is equals to AE, which we don't know. Is equals to BE. BE is 10 over AE. Okay. So for us to get AE, that means AE is gonna be 10 over cos 40. So what is 10 divided by cos 40 degrees? 13.05. That means AE is 13.05 meters. Okay. 7.3. Calculate the length of AC. Okay. Where is AC? AC is in, can you see AC is only in triangle AEC, if I'm not mistaken. I don't see it in any other triangle. So it's in this triangle. And in that triangle, we now know AE is 13.05 and this is 8.6. We know angle 70. Which rule do we use when we are given two sides and an included angle? It's a cosine rule. So we're going to use a cosine rule. A cosine rule, it said a squared is b squared plus c squared minus 2bc cos a. So our a squared in this case is ac squared. Sorry, b squared will be ae squared plus ec squared minus 2ae aec cos 70 degrees. AC squared will be AE is 13.05 squared plus EC is 8.6 squared minus 2 into 13.05 into 8.6 cos 70 degrees. So let's calculate this and see. Squared plus 8.6 squared minus 2 into 13.05 times 8.6 cos 70, 167.599. That's AC squared. That means AC square root of this 12.94. Yeah, 12.94 meters. That's the length of AC. Okay, so that one was quick. I can try give you guys the last one on the thingy, on those graphs, trig functions. Let's see which one we're gonna do on that one. So choose quickly. So on the trig functions, we've got this one where you are given just the function, and yeah, you've got this one or this one. Which one do you guys want? There's another one. So there's this one, 7 marks, or this one, 13 marks, or that last one, which is 11 marks. So which one should we do with the extra minutes I'm giving you guys?
The 11 marks, ma'am.
This one, okay. All right, so let's quickly do that. Let me just get to it better on my book so I'm able to read it from there. Question 6, the grade 11 one. Where is it? Question 6. Which one is this one? Oh, okay, this. Okay, let's see. Okay, you are given a graph. 1, 2, 3. Minus 90, minus 180, 0, 90, 180. Then you've got the asymptote here. You've got the asymptote here. And then you've got here, there, and -1, -2, -3. Okay, that's that. Then we've got this one, graph G. This is point Q. And then you've got this. What am I doing? I mustn't touch here. Okay. This is point P, 58 degrees and 1.6. And then we've got K. It's actually here and on -1. So this K and M. So K and M, they're actually sitting right here on 2 and -1. Eh? And then what else did I leave out? This is function F. What else is, okay. So the graph of the functions, f at x, which is equals to a cos b theta, and g at x, which is equals to c tan theta, for this is the limitation where your domain is between -180 and 180 degrees. As sketched below, the graphs intersect at point P, which is 58 degrees and then 1.6. Right. And they also intersect at Q. So they intersect at Q also. Question 6.1, write down the range of F. Range of F. We said the range is the Y value. So Y is an element of F is the cosine angle. So can you see, maybe I did not give the graph the proper view. Let's look at it from here. If we look at the range where the graph start, can you see the graph start at -3? So the graph start from -3 and the graph end at +3. So the graph doesn't continue to -infinity. You can see the graph curves here at -3, the cosine graph. Okay. So I just wanted to show you because I didn't draw it to scale, so it won't, I didn't do justice to where it's curving. So that means our Y is an element of -3 and +3. They are all inclusive. So that's that. Or you can write this as less or equals to 3, greater or equals to -3. Either way you write it, it's still fine. Then 6.2. If M is 45 and 1, if M is -45 and -1, where am I? If M, which is for -45 and -1, lies on graph G, determine the values of C. So they say M lies on, it's on this level. Okay. So they say M is -45 and -1, and it lies on graph G. This is graph G. Determine the value of C. Okay, so we have Gx being C tan theta. Remember what we said about T, it was A, it's an amplitude. So it's the height of the amplitude of your function where your values end. So if you see here, they said M lies on that graph. So we have -1 and 45 here. Okay, then what will be the value of C? So you see we've got the points on the graph. The graph Y is C tan theta. Okay, and we know the value of X on this graph. We know X is -45. We know X is theta in this case, so that's theta. We know theta is -45. We know Y value is -1. So we have -1 is equals to C tan -45. We get the value of C. So if you calculate C, your C is gonna be -1 over tan minus 45. And tan minus 45, it should be -1 also. So C is -1 over -1, which is 1. So that is C. Therefore, that means graph GX is actually just tan theta because C is 1. Okay. So that's that part. Then 6.3. They say write down the values of A and B. Values of A and B. A and B for the graph cos F, which is the cos function. A is cos B theta. First, we said A is the amplitude. So can you see the height of the graph? You see is 3. That means A is 3. So this is 3 cos B theta. And then we said this one is where you get it, either it doubles your, it changes your period. Okay, so it changes your period. So if you look at this graph, the period of this graph will be, let's see if it turns here. Because if it turns here, it's 91.8. Can you see it turns here? Is gonna go and pass at 270, and then the period here is still 360. The normal, the original period, the period here is still 360. So if this period is still 360, that means this B is 1 because it doesn't change the period. If the period maybe was 180, then we will know, okay, remember the new period is the old period divided by this value of B. So let's say the period was 180 if we checked it here, but it's not 180. You see, half a cycle is 180. That means the next cycle is going to be another 180. The full cycle, which is your period, is 360. So your cosine graph here is 360, the period of it. So if it's 360, that means the old period was 360, the new and then the new period is still 360 because we know the original period for the cos graph is 360 divided by B. That means our B is actually 360 over 360, which is 1, because nothing changed on the period. Let's say, for argument's sake, the new period here was, instead of 360, it was 180. Then that means you are going to have the new period being 180, and the old period was 360. This is the original period of the cosine graph. Divided by B, we want the value of B will be 360 divided by 180. That means in this case, the value of B was going to be 2. If that was the case, we were going to have our fx being 3 cos 2 theta, but that's not the case. In this case, our old period and the new one, the original period and the new one are still the same. Therefore, our B is 1. So that means A is 3, B is 1. This function fx will be 3 cos theta. Okay, so that's that. Then 6.4. Let me put this one here. 6.4, they say determine the coordinates of Q. Change the pen. You see where Q is. Can you see Q is the point of intersection of the tan graph and the cosine graph? And also they told you that the graph intersect, those two graphs intersect at P and Q. And you see the other intersection. So the graph intersect here and there. And that point of intersection, they gave us the values, is 58 and 1.6. So P was 58 and 1.6. 1.6 is just the amplitude where it intersect. That means even this side is gonna it's gonna intersect at 1.6, but on the negative side. That means actually here we have negative 1.6. So Q here, we don't know theta, but we know that the Y value is negative 1.6 because that's the point of intersection. If it intersects at 1.6 here, it will intersect at the same point. So that means our Q, we don't know the theta at the moment, but we know the Y value is 1.6, not degrees, just 1.6, okay? So for us to get the y value, that means we're gonna take, to get the x value, sorry, we're gonna take this y value, substitute it in the cos function or the tan function, whichever one you want, because they are on both graphs. So let's say we're gonna use the tan graph. So we have y is equals to, what is our tan graph? We checked it here. Okay, where is it? Y is tan theta. Okay, y is minus 1.6. Let's get theta. So theta is tangent of negative 1.6. Let's see that. Tangent of negative 1.6, which is negative 57.995. That is theta. So it should be positive. Let me see if I use the other one, the f function. This was 3 cos theta. I had negative 1.6 is 3 cos theta. That means cos theta is negative 1.6 over 3. Then what is theta? Inverse of this over 3. So it doesn't matter which one you use. So let's see. Inverse of that divided by negative 1.6 over 3, 122.23. So on this one, you're gonna add 180 degrees to get your angle, because this angle, this side is a positive one, it's not a negative. So that angle is 122.23 degrees. So that means, what was the question? Coordinates of Q. That means coordinates of Q is 122.23 and negative 1.6, not degrees. Why do I keep on writing degrees? So that is your coordinates of Q. That's how you get that. Then number 6.5. They say K lies. Okay, I deleted the wrong things. Okay. They say K lies on F such that KM is parallel to, let me just clean here so I can read and write. Okay, so 6.5. They say K lies on F. So there's K. Which colors haven't I used? Let me use orange. There's K. K lies on F such that KM is parallel to the y-axis. So KM is parallel to that. You know, parallel lines, they have the same gradient. Okay, that's that. Then they say calculate the length of KM. So they said KM is parallel to the y-axis. Then they want you to get the length of KM. Okay, so you know the length is the maximum, the y value at the maximum point minus the y value at the minimum point of that line, which is the y at K point minus the y at the M point. What is the y value? You can read it from the graph. You see the graph is at 2. So the y value is 2. The y value at M is minus 1. Yeah, minus 1. So that means this is 2 plus 1 is 3. KM is 3 units. So that's how you get that. Okay. Then 6.6. If the system of axis is shifted. Okay, wait, let me just go back here and see if I rewrote this correctly. If this, okay, yeah, it is like that. Okay, so 6.6, they say if the system of axis is shifted 45 degrees to the left. So they say the system of the axis is shifted 45 degrees to the left. And the graph remains fixed. So the system of the axis is shifted 45 degrees to the left. and the graphs remains fixed, write down the equation that is now represented by graph F. So they say the system of the axis is shifted 45 degrees to the left. So you've got your, what color am I gonna use now? That I haven't used, let's use purple. So they say your system, this system, your axis shifted 45 degrees to the left. So this axis shifted 45. So that means you're now let's do this so I can, yeah. That means now 45. That means the origin is now here. Here is your origin. It shifted 45 units to the left. 45 degrees, I mean, the axis itself. The graph remained fixed, but we shifted the system. Then they ask you now, write down the equation that is now represented by F. What is going to be the F at X now? Okay, so the axis shifted 45 degrees to the left. Okay, that means if the system shifted to the left, that means actually our graph shifted 45 degrees to the right. Okay, so if the axis shifted to the left, that means the graph itself, it shifted to the right by 45 units. And remember, from initial those nodes, when your graph shifts to the right, are we adding or are we subtracting? Remember, your original F at X is what? It's, where is it now? Let me check now. F at X is, where are you? 3 cos theta. Okay, so we are shifting it to the, we shifted it to the right. So that means we've got 3 cos theta minus 45. When you shift your graph to the right, you have a minus. When you minus that, that means you are shifting your graph to the right. When you plus, you are shifting your graph to the left. Let me just make sure this is what I gave you guys, the notes I gave you guys earlier. Yeah, so when you minus, you are shifting your graph to the right. When you plus, you're shifting your graph to the left. So I think this was the last question. Now I closed the whole thing. Yeah, that's the last question. Okay, any questions? Are you guys happy?
Yes, we are, ma'am.
Okay. Will you be able to get your 23 marks, your 12 marks, and what was, how much was the other question? So if you are happy here, then that's almost 50%. Not 50 though, because I think your marks are out of 150. So you've got like something around 50 marks already for those questions that we've done, or even 70, because now I don't remember. Let me just see here. So if you can master those ones, because you see, it's 28, 23, which is giving you something around 50, 60, and we did which one? This one, we did that one, and then we did this 80, and we did this, which is 11. About already, you see, about 80 and 90 marks already on your paper. Okay, it's on different papers because the other functions are under paper 1. Okay, so any questions, guys? I am now done.
No.
No, thank you. I'm okay.
All right. Okay. All right. So those that those that don't know me, I do these lessons not the free lessons. The free lessons, I only do them once in a while. So maybe the only next free lesson it will be maybe just before you guys write exams. But if you need my services and your parents, or you can talk to your parents, if your parents are willing to pay, you can talk to your parents and we can have lessons maybe once a week or twice a week, depending how struggling you are. So I offer the one-on-one lessons. So normally I do them on weekends. During the week I do, but I don't prefer during the week because I work and also I need to cook in the afternoon, and yeah. So if for those new people, Siyabonga and the TD, I always forgot your name, but I think it's what's your name? Andy, so I think. So yeah, so that's what I do. Otherwise, you can just follow me on my Facebook page. Sometimes I do post I just record videos and post them there also on free lessons. And do you guys want the recording for this?
Yes, please, ma'am.
Are you all on the WhatsApp group?
Yes, please.
I'm not on the WhatsApp group.
Okay, I have your number.
Yes, I am.
On the WhatsApp group.
Okay, so I have I've got Sinamila, I've got your, I don't have your, I've got your mom's number. So I will ask your mom to send me your thingy, your numbers, ne? Or write my numbers down. 072
272
984 0013 0013.
Okay, thank you, ma'am.
Yeah, so Sinamila, you can also write it down. Then you can send me a WhatsApp. Then I'll send it directly to your thingy, to your number. So I'll save the video on YouTube. Then I will just share the link so you can watch it from there.
Thank you, ma'am.
All right. Hope to see you guys next time and all the best.
Thank you.
Thank you.
All right.
Thank you.
You're welcome. Bye-bye.
Bye.
Bye.